Hello, everyone joining us. We're going to wait a few minutes. We've got a pretty large sign up, so we're going to give everybody a few minutes to get logged in. Just a heads up, we are recording this webinar. We cannot see you or hear you, so that will not impact you at all. And the video will be available on the city's YouTube site later next week. Again, we're just going to wait a couple more minutes. While we're waiting for more people to join us, I'll just kind of mention a couple of programs we have coming up. As part of this NASA at My Library grant program, there is a solar system display on the Oso Creek Trail. It's called Jump to Jupiter, and it's a scale model of our solar system from the sun to Pluto. If the sun was the size of a grapefruit. It's an easy walk on the trail. It's about a quarter mile, so half mile there and back to your car. It's located at the Pataki Center trailhead, and you just want to park in the lower lot of the Pataki Center, and you can get it from there. We're asking people to submit their Pluto selfies, and we'll have a prize drawing. Should be a lot of fun. It's a nice active learning process. And then next Saturday for ages 6 to 10, we've got a program called Reading Rocks. It's where children 6 to 10 can practice their reading skills. They'll read to volunteer teenagers. We'll be holding that outside in the Kershaw Garden next Saturday, August 7th. It's from 11:30 to 12:30. Seating is limited, so you will need to sign up, and you can sign up using the library programs email, which is libraryprograms@cityofmissionviejo.org. Same email you used to sign up for this program. And that's it for that. And I just realized I did not introduce myself. My name is Sandy Breimer, and I'm one of the librarians here at the Mission Viejo Library, and I'm happy that you guys have joined us today. I'm going to turn this over to Richard Stember, who's been working with me on this grant, and we should have a lot of fun with his presentation. So go ahead and take it away, Richard.
Thank you very much, Sandy, and welcome everybody. We've got some fun things to talk about tonight or this afternoon. I'm actually in 2 different places, if you can believe that. Or maybe 3 different places. I'm here in the Lake Forest, right next to Mission Viejo physically. And it's 4 p.m. right now. And we're talking about the planets. And we're going to be hopefully showing you some imagery of Jupiter and Saturn today. At the same time, I'm communicating with telescopes in Chile, in South America, and also on the Canary Islands off the western coast of Africa. So that's what I meant by I'm kind of in 3 places right now. So if you see me looking down or looking at at other screens on my monitors, and I've got 3 of them on my computer working right now, it's because I'm constantly checking the status of what's going on at the observatories. So as I mentioned, today's topic is the planets. We're going to talk a bit about the planets in our solar system and show you some really cool images of those planets and answer your questions. As we go through today's presentation, you're welcome to type questions into the question box, and we'll do our best to answer those questions tonight. But let's get this party started. And we're going to focus mostly on Saturn and Jupiter, but I welcome questions about any of the planets or even exoplanets if you have an interest in planets outside of our solar system. So as Sandy mentioned, my name is Richard Stember. I'm the executive director of a local nonprofit called Science Heads. We have a mobile observatory, and we bring that to schools and libraries and museums and put on nighttime events where we use our own telescopes to view planets and nebulas and galaxies, give the public once in a lifetime type of view of some amazing objects. We even have solar telescopes, which makes it possible, to safely view our sun and see prominences and sunspots and all the kinds of activities that the sun is producing. Well, it's still the daytime here, so obviously I'm not able to use our own telescopes, but hopefully we'll be sharing some images from some of the remote telescopes that we have access to as well. I'm also a volunteer with NASA. We're called Solar System Ambassadors, and we give talks about NASA programs and exploration of planets and moons in our solar system and plans for going outside of our immediate orbit to Mars and maybe one day outside of our solar system as well. But today we're talking about our own planets, our planets here in orbit around our own sun. And I've got a diagram here showing the order of our planets. Now, when I was growing up, when I was in grade school, we were taught there were 9 planets. Nowadays, of course, the students are taught there actually are 8 planets. This was a change which occurred in 2006, and it generated and still does generate a bit of controversy. Poor Pluto got demoted. It's no longer referred to as a planet. It's now referred to as a dwarf planet. And there's actually several dwarf planets that have names. These are large bodies that are in orbit around our sun, but don't meet the criteria anymore for being called a planet. And I'll explain what that criteria is in a little bit. But as you know, the innermost planet is Mercury. Then the next planet out is the planet Venus. Both of these planets, by the way, are naked eye visible planets. You can actually see them if you know where to look and when to look. And we'll talk a bit about that this afternoon as well. Earth is the 3rd planet from the sun. The 4th planet, the next planet out, is Mars. And the planet after that one, the king of all the planets, is the planet Jupiter. We call it the king because it is the largest planet in our solar system. It rules over the solar system in several important ways. It's not a king in the sense that it has a throne and it creates laws and forces us to do things, but it does force objects to do things in our solar system by virtue of its super large size, its mass. It's the largest gravitational force in our solar system, second only to the sun, of course. So comets and meteors and the planets themselves in our solar system are all at different times affected by the planet Jupiter. And that's why we call it the king of the planets. And we'll talk a bit about Jupiter in a few minutes. The next planet out, and the second largest planet, is Saturn. It's best known for its rings. And if you ever are offered an opportunity to look through a telescope at the planet Saturn, I suggest jumping at it. It's quite a rare treat, I should say. It's a really beautiful planet to look at. Jupiter is pretty beautiful as well, but my favorite is actually Saturn, second only to Earth, because that's where I live. The next planet out is Uranus, and then comes Neptune, and lastly, poor Pluto, which is no longer known as a planet. It's now called a dwarf planet. All of these planets orbit around the sun in basically the same plane. If you think of a desk, and if you had balls representing or marbles representing each of these planets, and you laid them on the desk, they would be in this plane. We call that the ecliptic. It's an imaginary line that runs across the night sky, and the planets basically follow that line when they orbit around the sun. And night to night, we can see the planets change their position along the ecliptic, this imaginary line. Now, to give you an idea of how that works, I'm going to introduce you to another piece of software here. This is a piece of software from NASA. It's actually free. You can download this on your own computer. It runs on a Windows computer. It's called Eyes on the Solar System. So if you Google Eyes on the Solar System and NASA, you'll find a page where you can download this software. And here we can see all the orbits of the planets. We see the sun at the center there. And we see the Earth, which is the third planet out after Venus. And then we see another orbit for Mars. We don't see Mars at the moment here. I have to zoom out a bit to see where Mars is. There it is. It's over here on the right. If I zoom back in a little bit, we can see where Jupiter and Saturn is. And the reason I'm sharing the software with you is we're going to use it to explore our solar system tonight. But notice, if I look edge on at the sun, you notice how all the planets line up onto this plane, the magic line in the sky we call the ecliptic. And in fact, after dark tonight, if you face the right direction, the correct direction, you'll see Jupiter a little bit below Saturn in the sky. You have to
Richard,
know where to look.
Interrupt for a second. We're not seeing that screen. We're still seeing the solar system slide.
Oh, thank you for mentioning that. Let me go ahead and change that. Okay. Well, we'll go to the next slide here. I'll see if I can fix that as we continue here. Since the definition of a planet changed in 2006, it's worth reviewing what we mean by the word planet. You know, ancient astronomers knew about 5 planets. They knew about Mercury and Venus, Mars, Jupiter, and Saturn. They observed them in the night sky. And this was thousands of years ago, 1,000 years ago. Egyptians and Greek philosophers, Roman astronomers, and the Middle East, what we now call the Middle East, observed these objects that amazingly changed position from night to night. Unlike the stars in the night sky, they did not, they were moving. The stars tended to stay in the same place in relationship to each other. And you know that we have names for constellations. Ursa Major, where the Big Dipper is. The Big Dipper always looks like the Big Dipper, right? The stars don't change position in relationship to each other. But unlike those stars, the planets actually do move across the sky. And they tend to rise in the east, just like the stars do, but they may rise earlier or later on different days, depending on what day and what month it is. So the ancient astronomers named them Planetese, which is the Greek term for wanderer. So you can think of the word planet meaning an object or body that wanders. And that was all good for many hundreds and a thousand years. Then in 2006, because of all the discoveries of new bodies, particularly in our solar system, but also new bodies outside our solar system in other solar systems in orbit around other stars, the Professional Astronomer Association, the International Astronomical Union, decided to come up with a little more precise of a definition. And the definition that they agreed to, after much discussion and debate, is roughly outlined here, which I pulled off of a NASA website. One, the object in question must orbit a star. So our moon does not orbit a star, does it? It orbits the Earth, therefore it's not a planet. And similarly, there's satellites or moons in orbit around Jupiter. So those are most definitely moons. Those are not planets. But the planet Jupiter definitely meets that definition. It orbits in a sort of circular orbit around the sun. The second part of the definition, it must be big enough to have enough gravity to force it into a spherical shape. So it must be round, a globe. There's many objects out there that don't look round. Small asteroids can have all sorts of funny shapes. You'll see asteroids shaped like potatoes and shaped like flat shards of rock. They take many different shapes. They're not large enough for their own gravity to force them into a round shape. So again, Jupiter and Saturn and the Earth, they meet that criteria. They're roughly round. And lastly, and this was an important criteria that they added, it must be big enough that its own gravity clears any other objects out of its path. And this is where Pluto kind of fell down. There's other objects that are in its path. It's not large enough to clear those objects out of the way. There's very few objects in Earth's path, and most of those are man-made. They're satellites that we've placed there ourselves. A planet needs to be big enough to kind of clear out the road, make it its own. And unfortunately for Pluto, it didn't meet that criteria. There's a number of other objects that are in its orbit. It actually crosses its orbit with Neptune. It goes inside of Neptune's orbit at different portions of its rotation or orbit around the sun. So that's one of the reasons that Pluto failed the test. It's no longer known as a planet. Another reason that not listed here, there's actually some objects that we found that are bigger than Pluto. And if we keep on finding objects like that, it's going to be quite a feat memorizing all the names of those planets. It's a lot easier just to remember 8 names. So this is how the astronomers figured it out. But science being what it is, science evolves. So the definition of a planet may evolve with it as well. Now, I mentioned you can actually see certain planets with your naked eye, with just your eyes, if you know where to look and where to look. I'm going to share with you some online tools which are free that'll help you find Jupiter, find Saturn, find Venus and Mercury. One of those is a sky map, like what I've displayed here. I'll share with you a link to download this map. It comes out monthly, and you see this dotted line on the map. That's the imaginary ecliptic. That's the line that the planets follow. So if we look off to the left here, we can see in the east, the left-hand side, we can see the planet Jupiter and the planet Saturn roughly on that imaginary line. This is the map for August, and it tells us up at the right-hand corner that early August at 9 p.m., if you look up in the east, roughly 10 or 15 degrees off the horizon, you'll be able to see the planets Jupiter and Saturn. And the way to use these maps is you hold them over your head. Like this, you hold it over your head and face the direction that's on the map. And it makes it really easy to find it. Of course, if you got a smartphone, you can also download planetarium software for your phone, and that'll make it very easy to find the planets as well. Jupiter is one of the brightest objects in the night sky. It's very easy to find. Saturn is a bit dimmer than that. Venus is the brightest of them all. If we look on the left-hand side of this sky map, you can see they list dates for August and special events which may be happening. There's a meteor shower coming up in August, the Perseids. On August 12th, it'll peak. If you get a chance to go out to a dark sky location like the desert or the mountains, the universe will put on a beautiful show for you. See a beautiful meteor shower. You can see where the moon is and what other objects are on the sky. So this is a very handy chart to have, and I'll share with you a link to download it. Another very useful online tool for finding the planets is at a website called Heavens Above. It's heavens-above.com. And on my last slide, I'll share with you the links for all of these websites as well. Now, this one takes a little bit of work. You need to first log in, or at least tell it where you're located. So it'll on the location list, you can pick Mission Viejo and or whatever city that you're observing from, and that will update the table. And notice there's a column for each of the 8 planets plus Pluto. And the important information here, real simple, to keep it simple, set the date, the month and date. The time doesn't matter so much. And then look at what time each planet rises and sets. Now, the times here are in 24-hour format, which is really very easy to work with. Just remember noon, lunchtime, 12 noon would be 12. And every hour after that is simply added to that. So we can see here that Jupiter rises at 20:53, 20 hours, 53 minutes. In other words, that's 8:53. in the evening. So if you go outside tonight and look in the east at 8:53 or after that, you can catch Jupiter rising in the east along that magic line called the ecliptic. And it will set at 7 a.m. in the morning, or almost 8 a.m. in the morning. Likewise, Saturn rises a little bit earlier at 19:53 and sets a little bit earlier as well. Another very useful piece of information here will give you an idea of the best time to look at these, the best day to look at these planets. And that's what we call opposition. And I'll explain what we mean by opposition in a minute. Opposition occurs for Jupiter and Saturn on the dates that are circled here. So Saturn is reaching opposition on those dates in 2021, on that date in 2021, August 1st, which is tomorrow. Now, what do we mean by opposition? This nifty diagram here explains it very clearly. Opposition is when the planet in question is on the same side of the Earth as the same side of the sun as the Earth. So we can see off to the right here, a planet is identified as being in opposition. Immediately to its left is the Earth. There's an inner planet there that could be Venus or could be Mercury, the two inferior planets in our solar system, and there's the sun. That makes it really easy to plan on seeing Jupiter or Saturn or any of the other planets if you know when their opposition is. Opposition also often occurs very close to when they are the closest to the planet Earth. So if they're on the same side of the sun and they're in opposition to the sun, they're going to be very, very close to Earth. And you know, as with any object, when an object gets close to you, it looks bigger, doesn't it? It's easier to see details on it. So tomorrow, Saturn is going to be at opposition. When we look at it through a telescope, it'll look bigger and brighter. We'll see more details than, let's say, 3 months from now. So that's very useful to know when a planet is going to be at opposition. The opposite, by the way, of opposition is conjunction, where a planet is on the opposite side of the sun. Obviously, that's not a good time to try to find that planet. The sun would be behind the sun, or the sun very close to the sun in the sky. So we'd be peering during our daytime hours. So as I mentioned, we plan to share with you live images from telescopes elsewhere. And I'm getting reports from those telescopes that they are having technical difficulties. So they were down last night. And unfortunately, the telescopes on the Canary Islands are down tonight as well. They're not operational. I'm getting word. So let me just double check here. There's several telescopes on the Canary Islands that we have access to. And unfortunately, they're not operational tonight. I'm sorry about that. That happens time to time. Technical difficulties, clouds, all sorts of issues can arise with telescopes. And I'm going to check the other. I'm going to check the other observatory in Chile and see if it's having any difficulties as well. So, okay, well, I'm monitoring that. Yeah, it looks like Chile is offline as well at the moment. Well, with a little luck, maybe they'll be able to get those telescopes back online. So let's continue on here. We'll I'll continue monitoring those observatories. Let's take a look at some pretty cool images of Jupiter and Saturn, which I've got for you here. So I mentioned Saturn is my favorite planet to look at through a telescope. It's often called the ringed planet. It's not the only planet in our solar system, by the way, that has rings. 2 other planets also have rings, albeit they're very faint, difficult to see. In fact, ground-based and space-based telescopes generally cannot see those rings. But spacecraft that we send to Uranus, Neptune, for example, detected very, very faint rings. We believe, like Saturn, those rings were created by either comets or asteroids captured by the gravity of the planet, or moons getting a little bit too close to the planet and actually being broken up into billions of pieces. If we study the composition of Saturn's rings, we discover that it's mostly ice, some water ice, a lot of carbon dioxide ice. We believe that may have come from comets that got into orbit around Saturn and were broken up by its gravitational pull. Notice in Saturn's rings, there are openings or empty paths, and they're actually not totally empty, but in fact, there are moons in many of those portions of the rings. The large gap that you see in the Saturn's ring, that is called the Cassini division. And in that division, as well as in some of the other divisions of the ring, are small moons or proto-moons that have been clearing the path of their orbit. And they can get rather large, some of these moons. Most of them are very small. Now, Saturn has 62 moons that we've confirmed their orbits for. 62. That's a lot of moons. We'll believe that it may have as many as 150 moons, many of which we haven't actually observed yet or discovered. In fact, of those 62, we've given 53 of them names. And no, I don't know all their names. There's a lot of moons, but they all have been given names based on mythical figures in Greek and Roman mythology. Some have names from other cultures as well. The most easily viewed moons of Saturn are Titan, Rhea, Dione, and Tethys. Titan is one of the most interesting moons. We actually sent a spacecraft there. Years ago, we sent the Cassini spacecraft to Saturn. And there was a smaller spacecraft attached to it called the Huygens probe designed by the European Space Agency. And that probe was released from the Cassini spacecraft, and it descended and landed on the surface of Titan. And we actually captured many images of that descent and the landing. And that probe lasted for many minutes on the surface until it eventually failed as planned. And what we discovered about that moon, Titan, was that it has liquid on its surface in the form of lakes and rivers, ponds. It's quite a dramatic landscape, but that it's not liquid water. It's actually liquid hydrocarbons, mostly propane and methane. So that stuff that comes out of your stove that you use to boil water when you're making spaghetti, that's methane. Here on Earth, under normal conditions, it exists as a gas. But Titan is so cold that methane actually turns into a liquid, and the same with propane. It rains hydrocarbons on that moon and forms lakes and rivers of propane and methane. Water does exist, we discovered, on Titan, but it is frozen as hard as a rock. So NASA is actually planning to send more spacecraft to Titan to learn more about its secrets. Who knows, maybe it harbors life. We've always known that life probably requires a liquid to form. Here on Earth, we believe it formed in our briny oceans, our salty oceans. Who knows, maybe different life forms came about in liquid hydrocarbons. Some other interesting facts about Saturn. It takes light about 33 minutes to reach us from Saturn. So when you do look at Saturn with your eye or through a telescope, you're seeing what happened on Saturn 33 minutes ago. It's kind of like looking back in time. Its orbit is not quite circular like all the planets. It's more elliptical than circular. So it gets closer to the sun and farther from the sun at different points in its orbit. On average, it's about 840 million miles from the Earth. And it takes 29.5 Earth years to orbit around the sun. But it rotates on its axis much, much quicker, more than twice as fast than the Earth does. Its day lasts only 10.5 hours. If we ever send astronauts to Saturn, they're going to have to be very well equipped. They'll have to wear spacesuits, of course. The atmosphere is quite poisonous to humans. That last bullet point there lists its components, largely helium, methane, ammonia, and hydrogen. But there's a potential of acids in the atmosphere, and it's certainly not going to be a very pleasant place to visit. Just checking the observatories again, and still we don't have any images to share with you from Canary Islands yet. So fingers crossed. Hopefully we get some, they figure out the technical issues and they get us some live images. One of the online observing tools that I'm going to share with you tonight. If you want to take a look at Saturn through a telescope or with a pair of binoculars, looking at the rings is always very exciting to do. It's one of the most beautiful features of Saturn, but also identifying the major moons of Saturn. There's 5 moons that can be easily seen with even a small telescope. And they're listed here on this slide. Sky and Telescope magazine, a wonderful magazine for amateur astronomers. I highly recommend it, as well as a number of other magazines, astronomy and others. But Sky and Telescope has on their website this observing tool that if you enter the date and the time you'll be observing Saturn, it'll tell you where the moons are. It'll identify their position. And here we can see tonight, we were hoping to see Titan and Enceladus, Dione, Tethys, and Rhea through our telescope, as well as the rings itself. And again, I'll list the link for this particular online tool, very easy to use. Turning our attention to the king of the planets in our solar system, Jupiter. Now, the most well-known feature of Jupiter, known as the Great Red Spot. Astronomers aren't known for creativity, especially with coming up with names. I guess that's why they rely on their mythology book so heavily. Someone many hundreds of years ago identified this round feature on Jupiter, and we see it in this image taken by Cassini, the Cassini spacecraft, in the lower right-hand quadrant of the planet. Modern day astronomers named it the Great Red Spot, or GRS for short. They studied it and determined it is a storm that has been raging for well over 300 years. In fact, it was discovered by Chinese astronomers more than 300 years ago. It's a storm that has been raging all that time. It has changed in size and shape and color as well. When it was originally discovered, it was quite red, hence the name Great Red Spot. Nowadays, it looks more orange brownish, and astronomers are still trying to determine why that is. No doubt it has to do with the composition of Jupiter's atmosphere. And you can see on this slide, there's a lot of sulfur compounds and methane-based compounds in the atmosphere. And that could explain the brownish kind of colors. To give you an idea of the size of the Great Red Spot, more than 2 Earths could fit across the width of the GRS. 2 or 3 Earths could fit in the Great Red Spot. It's huge. It's been likened to a hurricane, although hurricanes are powered by the ocean and warm water and warm atmosphere. As our climate warms up, we expect hurricanes to get stronger and stronger because of that. We don't know of any oceans on Jupiter, so it's purely an atmospheric event, and it is one of many storms on the planet, in the planet's atmosphere. In fact, the Great Red Spot every now and then gobbles up smaller storms. We can see in this image some smaller whitish type of storms in a lower latitude there on the planet.
Richard, someone
Yes.
has asked, do we know how intense the storm is? Like, what's it? Is there like thunder and lightning, or? Do we know wind speed? Do we know anything like that? Its intensity?
That's a wonderful question. Thank you for that question. We have measured the velocity of those winds up to about 600 miles per hour. So it's quite intense. The atmosphere is very dense and thick. So it's unimaginable kind of forces going on there. It's not quite the strongest wind velocities in our solar system, though. I believe a similar type of storm on the planet Neptune, we've measured wind velocities of up to 1,000 miles per hour. But it is very, very intense. In terms of lightning, we believe we actually have detected lightning on Jupiter. And in terms of precipitation and such, it's quite likely that there is precipitation, although it's not likely to be water. It's likely to be sulfuric acid or other very nasty kind of compounds. So thank you for that question. It's a wonderful question. Jupiter is very much a planet of extremes. It also has about a 10-hour day, as opposed to our 24-hour day here on Earth. It rotates on its axis every 10 hours. And it's about 10 times wider, or its diameter is 10 times larger than the Earth's. So imagine 10 Earths fitting across the face of the planet. A huge planet rotating more than twice the speed of the Earth on its axis. That helps explain the cloud bands that you see on the planet. You can see those brown bands just north and south of the equator there. Think of it as a blender where the layers are layers of different materials are forming inside the blender. The cloud bands are easily visible through a standard or a medium-sized telescope here on Earth. As is the GRS, can be viewed from here on Earth if you know when, because the planet is rotating rather quickly. So there is a tool on the Sky and Telescope website that will give you an indication of when to look for the GRS, what time here on Earth that you'd be able to observe it. 436 million miles on average from Earth, so it's quite a distance away from Earth. And it has many moons as well, 79 known moons, all of which I believe have been named, 4 of which are easily visible with a telescope, from a telescope here on Earth. Those are referred to as the Galilean moons, because Galileo himself discovered these moons in 1610. He was the first person to take a telescope and point it at the night sky. Telescopes had been invented by another scientist a few years earlier, and they were mostly at that time being used for nautical purposes, looking at ships and on the sea. That's where they became very popular. But Galileo turned his telescope towards the night sky, and one of the first objects that he observed was the planet Jupiter. And that first day of observation on January 7th, 1610, he noticed 4 stars in close proximity to Jupiter, and he made a note of that in his notebook, his scientific notebook. By the way, we have that notebook. It's on display at a museum, the Galileo Museum in Florence, Italy. And over a series of nights, he kept on turning his telescope to Jupiter, and he noticed that those points of light that he thought were stars were changing position. they were in a different place each night. And he deducted from that observation that those were actually moons of Jupiter. They were in orbit around the planet Jupiter, which, by the way, further strengthened his agreement with the theory that the Earth orbits around the sun. Up to that point in time, the common thought was that the Earth was at the center of our solar system, in fact, at the center of the universe, and everything orbited around the Earth. Well, Galileo didn't quite believe that, and observing the moons of Jupiter just confirmed that for him. If moons could orbit around a planet like Jupiter, then it made a lot of sense for the other planets to be orbiting around the sun, at least to Galileo. Got him to a lot of hot water with the religious authorities of the time, the political authorities as well. So it's one of my favorite planets to look at. It was also one of Galileo's favorite objects to look at, as well. And those 4 moons, the Galilean moons, which are Io, Europa, Ganymede, and Callisto, are easily viewed through a small telescope or even a pair of binoculars. And the Sky and Telescope website has a tool for determining where they're going to be when you're looking at Jupiter. Here's where they are tonight at this time. We can see Callisto off to the left there, Io immediately to the left of the planet, Ganymede and Europa both on the right-hand side of the planet. Each of these are incredibly interesting moons. In fact, NASA has identified Europa as being a prime target for its search for life, because we believe Europa is covered in a frozen shell, a frozen surface, and below it, we believe, is a briny ocean, much like our oceans, salty water. And how do we know this? Well, we've actually measured. We've actually measured and discovered water vapor emanating from geysers on the moon, Europa, in cracks of the surface. We've imaged those cracks. We sent a spacecraft there, the Galileo spacecraft, took amazing images of Jupiter and many of its moons as well. So it's an amazing object to look at. Unfortunately, here on the ground, we can't see much more than just a dot where the moons are, just a faint white dot. But it's still fun to know that that's one of the moons that Galileo observed back in the 1600s. Just checking on our observatory here. And
while you're checking, Richard, we do have a couple, I don't want to say off topic because they obviously deal with the planets. We have a couple questions I can throw at you if the
Please.
Telescopes don't come through. Addison is asking, and I think I'm understanding the question. What do you want to see from a telescope? Is there something maybe you like on your wish list that you haven't seen yet?
That's a very fun question. Thank you, Addison, for that question. There are so many objects to look at in the night sky through a telescope that you could spend every night for the rest of your life looking at a new object if you could. One of my favorite pastimes is getting out to a really dark sky, away from all the light pollution here in Orange County, going up to the mountains or out to the desert, maybe Joshua Tree National Park, and first observing this night sky with just your eyes. You can see the Milky Way in all of its glory, and then turning the telescope to the stars and looking at stars that are just forming, stars that long ago exploded and left nebulas where they once were, stars that we believe are actually have companions, actually are 2 stars or 3 stars or 4 stars that are in orbit around each other. There's tens of thousands of known objects like that that you can look at. If you have a telescope that's either computerized, or if you have a sky chart and you know the coordinates of those objects, you can find them. And hunting them down and looking at them and thinking and realizing that what you're seeing occurred thousands, sometimes thousands or tens or hundreds of thousands of years ago. What you're seeing is light that left that star many, many, many years ago and is just reaching the Earth now and reaching your eye. Is very exciting, very interesting. So yes, there are many objects that I love to look at and would love to still see. Someday, I hope that we'll have telescopes that are powerful enough to see a black hole, or to see all the way back to the beginning of the universe, some 13.6.7 billion years ago. Scientists and engineers are working on those kind of possibilities, and NASA is building new telescopes to send into space. So thank you for that question. Sandy, was there another question as well?
We do have another one. Someone is asking, did an asteroid hit Pluto at some point?
Oh, yes. In fact, you can count on every planet, every moon in our solar system has experienced that, where asteroids, big and small, have crashed into them at some point. You know, the most spectacular, from our perspective, may have been the protoplanet, the small planet early on in the history of Earth that crashed into Earth itself. Very early in the evolution of Earth, a protoplanet crashed into it, we believe, and broke off a big chunk of the Earth, sent it into space, into orbit around the Earth, and eventually all of that material from the mantle and the crust of the Earth coalesced and formed into our moon. And that's how we think our moon formed. This cataclysmic event, long before there was life on Earth, formed the moon. Getting back to Pluto, we sent a spacecraft there a few years ago, the New Horizons spacecraft. It flew by Pluto very quickly and got some great pictures, at least of one side of Pluto. Also some pictures of its 2 companions. And sure enough, there's evidence of craters and impacts on Pluto as well. So at some point in time, yes, an asteroid, many asteroids, big and small, may have crashed into Pluto. Comets as well. Excellent question. Thank you for that. So we're all kind of disappointed tonight, I know, because we're not able to see any live images from the observatories. Sometimes that happens. Sometimes there's technical issues. Sometimes it's clouds. I know the astronomers there are working very hard to try to get the telescopes up and running again, connected to the internet so we can use them. Unfortunately, it's not going to happen during this hour. But if you want to, you can actually use these same telescopes. Kids, if your parents say it's okay, you can sign up for a subscription It's very inexpensive, $20 for a year, I believe, for these remote telescopes. It's the slew.com website. So even if you don't have your own telescope, you can control these telescopes and capture images of the planets from where these telescopes are, off the coast of Africa or down in South America. So I highly recommend browsing over to slew.com, checking out the kind of images and objects that have been imaged by other amateur astronomers there. If you want to see the planets with your own eyes, download the star chart that I listed the website for here. Be sure you're picking the one for the right month. And if you want to see where the moons are of Saturn and Jupiter, if you want to find out exact times that the planets are rising and what days they're at opposition, I've listed those links at the bottom here as well. There's so much to see, and there's so much fun to have. Even locating the planets with your eyes, if you know where to look, it's not hard to do. And if you have a telescope or would like to use a slew telescope, there's plenty of opportunities to explore, the solar system and our universe. So I want to thank you for your questions. Sandy, do we have any more questions there?
We've got two more if you've got time.
I do.
Addison, you're coming up with great questions. Is another planet going to form?
Oh, well, that's a very good question, Addison. I hadn't really thought about that. But we know planets are forming around other stars. You know, I mentioned at the beginning, we're talking about planets in orbit around our sun. But we've discovered close to 1,000 planets now that are in orbit around other stars. And early in that hunt for exoplanets, as they're called, astronomers actually captured some images of one of those stars. It's a nearby star, and a cloud of material in orbit around it. Now, that cloud of material can be asteroids and comets and dust and gases, and that's the material that planets form out of. You remember, in the definition of a planet, it's got to have enough mass to form a sphere. Its gravity must pull itself together. Well, gravity is what does the trick there in that cloud of dust around that planet. Over millions and billions of years, gravity will pull together some of that material and form planets. So yes, for sure, planets are forming right now, probably not in our own solar system, because our solar system is, 4 billion years old? And that the cloud that originally existed around the sun has pretty much been used up. All the planets that are going to form out of it have formed out of it. But in newer stars elsewhere, I'm sure, astronomers are sure that planets are forming as we speak. So Addison, thank you for that question. That's a wonderful question.
And then someone wants to know, how did the moon get its craters?
Well, that's a good question too. So all those craters were the result of objects like comets and asteroids, meteors crashing into the moon. So when you look at the moon, you look at a picture of the moon and you see craters, that means that at some point in its past, something crashed into it. you could do the same thing if you were at the beach, for example, and you drop a stone, a rock, onto the beach. You'll make a crater, won't you? Well, the rocks that were crashing into the moon long ago were much bigger generally, and they made some pretty big craters. We've discovered that the side of the moon that faces us, because one side of the moon always faces us, it's called gravitational lock, or tidal locking. So one side of the moon always faces us, which means there's a side that faces away from us. And we've taken pictures of that side, and it has many more craters than the side that faces us. And that's because it's exposed to more of the universe. So excellent question. That's where craters come from.
Okay, we've got one more and then we're gonna wrap it up. I'm missing some keywords, so I don't know if there's a character limit in the chat or not. So I'm gonna summarize. I guess, can you tell us what's the coldest planet in our solar system?
Coldest planet. That would be, in all likelihood, the furthest planet from the sun. So that would be Neptune. It gets the coldest there. In fact, if you were at Neptune and you looked towards the sun, it wouldn't look much bigger or brighter than any other star in the sky. You know, here on Earth, it's pretty warm, 80 degrees Fahrenheit or hotter today, primarily because of the light that comes from the sun. And we're pretty close to the sun compared to Neptune. We're very close to the sun. Neptune is many, many times further away. And that means much less light from the sun reaches Neptune, and much less heat from the sun reaches Neptune. So it would be the coldest planet for sure. Pluto could be colder, but remember, it's a dwarf planet now, so we can't say it's a planet anymore. But Pluto is so cold that nitrogen gas freezes and snows on the surface. So when it's furthest away from the sun, the surface of Pluto is covered in a whitish snow made out of frozen nitrogen, which occurs here on Earth as a gas. You breathe it, that's in the air. That's mostly what air is made out of. So Neptune is probably the coldest planet. Pluto, probably a little bit colder. The further you get away from the sun, it's going to get colder yet. Thank you for that question.
Okay, that's it for our questions. I want to thank Richard very much for providing us with this great educational opportunity. Like the rest of you, I'm a little sad we didn't get to see anything live, but he's given us some really good resources, and I will email out the links to you guys actually in just a little bit so that you've got them to use. And if you have any questions about anything, feel free to email the library programs, or you got a reply mostly from me. You can email me directly and we'll go from there. So I think that's it for the evening, and I hope everyone has a good night. And thank you again, Richard, for this. It was great.
It's my pleasure, and I hope that we can do this again and share some live images from the telescopes next time. So
we will certainly try.
Thank you, everybody, for your questions. Bye-bye now.